Welcome back to Housebuild TV. This evening we're going to discuss building regulations part B2 to B5, and let's welcome back Geoff Wilkinson from Wilkinson Construction and Eoghain Ryan from Ryan and Associates and Housebuild.co.uk. Thanks for joining us again, Geoff, and let's get started.
Pleasure as always. Pleasure as always. Yeah, so just to briefly recap, the last time we were chatting, we had a dive into B1. So the plan today is that we're going to take a look at the rest of approved document B, again, focusing just on housing for the moment. So we'll be running through B2, B3, B4 and B5. So a nice little compact section tonight, running through those various bits. So shall we start with B2? B2 is all about wall linings. Now, a lot of the discussion up until now has been about fire spreading external walls. Everyone will have seen, I'm sure, all of the debate in and around Grenfell Tower, external cladding panels, things of that kind. But what's often forgotten is that the internal surfaces of a building also need to ensure that they don't spread fire as well. And that's where, in particular, B2 comes into play. This deals with wall and ceiling linings within a dwelling, and there's lovely classifications such as D, S3, D2, which will mean virtually nothing to anyone other than meaning that you've got to go off and check that whatever products you're using will actually have some form of fire test to confirm that they will reach that clarification. The purpose of this, I say, essentially is to ensure that if a fire occurs in one part of the property, it doesn't spread via the wall and ceiling linings into the escape routes and cause problems that way. For those of us that are old enough to remember it, in the 1970s, there was a huge trend for people to modernize their homes by sticking polystyrene tiles on their walls and ceilings. And that's possibly one of the worst things that you could have done. The polystyrene ceiling tiles themselves are highly flammable, and if you were to then add a couple of coats of paint over the top, you really would have the perfect oil-based route for which fire can spread. And not only does it spread, it spreads very fast, probably faster than most people could get from one side of the room to the other. And on top of that, you've also got concern over what's known as flaming droplets. Now, this is where parts of the tile become molten, and you end up with flaming molten plastic coming down on you, which can both spread the fire itself and not do you much good either were it to land on you. So that's something that should be particularly avoided. Now, the best recommendation I can give is to not put burny stuff onto your walls or ceilings. Just avoid stuff that burns. That would be a really, really good idea generally, especially plastic or oil-based burny stuff, because that's the worst. I have seen people who put the false plants, the plastic plants all over the ceiling, make a lovely green ceiling. Again, that burns. Not a good plan. So try and avoid putting that on in the first instance. Now, something that does need to be mentioned, so a good choice would be like plasterboard. Plasterboard, generally speaking, is not burny stuff, so don't worry unduly about burny stuff if you're using plasterboard. But something that people will regularly use in these areas, of course, is timber. So can you use timber? Well, the first thing is yes, particularly doors and window frames, architraves, the moldings, picture rails, those kind of things in particular are absolutely fine. And you can also use a smaller part of the wall and have that timber clad, for example, because that won't cause the fire to spread all around the room. But ideally, as I say, plaster is a great finish. You can use tiles. Wallpaper is acceptable on top of a plasterboard or a non-flammable underside. So yeah. Oh, yes. So alongside that, another thing that we do see from time to time is that the ceiling itself is actually formed of a glass roof light, for example. So when you look up, the surface that you're actually seeing there is a roof light. Sometimes that can be a plastic panel. So again, there are limitations if you're using any form of thermoplastic. So it could be in downlighters, it could be in the roof light itself. If you've seen these like sun tunnel type things, that bring the light down into the center of the room, you want to make sure that anything that you're putting into these are not essentially going to melt and drop and flame out. So yeah, that's probably the sort of core bits to keep an eye out for on B2, which is about the surfaces that you've got. There are no requirements in building regs actually on the floor surface. However, we would normally say that the ideal sort of floor surface, if you're going to have carpets or whatever, is a mix rather than the modern plasticky formed versions of the carpets that you can get out there. So if you can get a wall blend or something like that, that's great. The timber finishes are fine, and obviously ceramic tiles generally are fine.
One thing is, so people have to watch out for slip resistance there. So in commercial buildings, you have to have slip resistance. It's not a B2 issue, but it's just an effects means of escape. And as Geoff was saying, if you buy an old house and you see wainscoting on a wall, sometimes that was used to hide damping behind it. So in older buildings, you would see a lot of this. The wainscoting was a great way to hide damp. So,
are you suggesting people would deliberately cover the floor?
No, I never suggest that, Geoff. No,
quite right as well.
I'm very trustworthy.
So the next bit from the inside is taking a look at what we refer to as requirement B3, which deals with the fire protection of the main structural elements. So what are the main structural elements? Well, it's anything that's performing the function of structure. So it's a wall, it's a beam, it's a column, it could be a lintel, for example. Any of these things that are actually holding the property up will need to have a specified level of fire resistance. Now, that specified level of fire resistance, generally speaking, is either going to be 30 minutes or 60 minutes in most of the properties. And the way that you look to establish that, you go to the back of the approved document, you look at the height and nature of the property that you're doing, and you read off from the table to work out what the required fire rating for the building is. Depending on whether you're in England, Ireland, Scotland, Wales, the tables are slightly different in positioning, etc. But if you take a look, I'm sure when the final version of this goes out, you'll have on screen an example of one of these tables. So you can just say literally read across what the height and scale of your building is and what the appropriate level of fire resistance is there. And it will typically be, as I say, 30 minutes or 60 minutes. Now, from that, you can then speak to the relevant manufacturers and you can determine how you're going to go about achieving that. Now, things like bricks and blocks, for example, have a natural inherent fire resistance to them. They're effectively non-combustible. They're not going to burn. You could light a fire and they'd still be stood in place 4 hours later, so you'll be fine on that kind of traditional build. On more modern builds where you're using, say, timber frame, for example, then the plasterboard that you use is likely to be the method by which you're achieving the fire resistance to the main building. And you need to think then as well about how you're going to detail that up, because any time that you punch a hole through that plasterboard, let's say for a downlighter in a ceiling, or speakers, or your Alexa, or whatever modern thing that it is that you're incorporating within your building, all of these things are breaches of that fire rated layer that's providing the fire protection to your structure. So you can get downlighters that have got fire rated hoods. You can get integral fire rated downlighters, likewise with speakers or any of these other options. Something that seems to be very much on trend at the moment, particularly in the domestic extension market, is people quite like this sort of semi-industrialized look. And what they'll tend to do is they'll tend to keep the steel beam looking like a steel beam rather than boxing it out with plasterboard, for example. So there are a number of products on the market that are effectively a fire rated paint that you can use for them. And this is where a whole sea of confusion tends to come in, because what you're looking for is paint that increases the fire resistance or provides fire resistance to the product. The paints that are out there often talk about, they may say they're fire rated, or they may say they have a surface spread of flame rating or various other bits. So it's quite confusing as to what the product actually does. You need to make sure that the product that you're using is suitable for exactly how you intend to use it. Now, in most cases, when we're talking about coating the steel beam, you would be looking for a product that has an intumescent property to it. Now, what that means is that effectively, when heat is applied to it, will actually swell up and provide additional insulative properties to the steel section itself. Normally, day in, day out, it will just look like a paint, but it will actually react in the case of fire to enhance the fire protection to that steel beam. In older properties, you can find all sorts of different products that have been used for it. Sometimes you can find like a sprayed vermiculite property to it. So there are some quite unusual variations to it. So if you do find any of those, keep an eye out for them.
One thing that, and again, I'd like you echo the point with that. People are very confused, but what people don't realize, if they look at tables A1 and A2, columns and beams have to be protected from the exposed face, and the exposed face is to where there's combustible material. If it's sitting into concrete, it's fine, but if it's exposed to timber surfaces, then it's exposed. And people, I've seen, I know many times you go to site that did have a beam supporting the floor and they have timber on it and joists and bridging into it, and they think the thing is protected. Oh, we only have to provide fire line board to the underside of it or plasterboard to the underside of it. That steel beam is exposed and it's a weak point in your structure. People need to realize that. And I've seen there's been a bit of an improvement on a lot of the online TV shows where they're doing remedial works or they're doing extensions. 5 years ago, there was no intumescent paint. Now you get intumescent paint creep in, but people have to realize it does affect the integrity of the steel, and it's an exposed face, so it should be protected before you put any kind of combustible material near it. And an issue with intumescent paint is it should have enough space around it to expand. And sometimes if you put timber in on top of it or bridging or joists, it can't expand fully, but it's not fully exposed to the fire, so there's a charring rate. So there is allowances that you can kind of look at, but in the clear light of day, it's an exposed face, it should be treated properly.
In fact, you briefly mentioned there about charring as well, which perhaps is something else that's another option that we perhaps should mention, that particularly with larger mass timber structures, they can be designed to have a natural charring effect to them. What this means is that there's effectively a sacrificial layer around the outside of the timber beam. So if you look at the really traditional old-fashioned houses, you'll often find massive timber beams within those, with no obvious fire protection to them at all. But actually, the natural property of the timber itself is such that initially the outside surface will char, and that will reduce down the timber section size to a smaller effective section, but it won't continue to burn beyond that. And it's quite a rare example, but you can actually get pre-charred timber, which effectively has a natural sort of charcoal face to it, which has a fire protection property naturally built into the timber itself. It's very much one for taste.
You see a lot of people, designers, do that on external walls now, where they might put a timber finish on it on the outside, and they char it. They would go around with a kind of a burner and char it, and then it gives a lovely kind of black look. As you say, it has inherent fire resistant properties because it's a carbon material.
Absolutely. We'll move actually on to external walls in a moment, but the next thing really under B3 that I wanted to touch on is about compartmentation. So in a single house, there's not a lot of need for compartmentation, unlike, for example, a block of flats. But the first thing to draw people's attention to is that a garage is considered to be a higher fire risk than the rest of the property, so that will need to be separated as its own independent compartment. Now, compartment basically means an inherent fire rated box, so there's nothing going in or out of that box that will allow fire to spread from that compartment to the rest of the building. So anything in the way of like a ceiling or a wall, a door, from the garage into the main house, or linking the garage to the main house, integral garages in particular I'm thinking of here, needs to be fire rated. And again, generally speaking, that would be a minimum of a 30-minute fire rating. Whilst we're on that subject as well, the floor of the garage should be set to ensure that either there is a fall away from the fire door, or that it's set at a lower level. Now, the reasoning for that is that if there is a fuel spill within the garage area, that the fuel won't be able to get underneath the door itself and allow fire to spread under the fire door in that way. So it gives you the protection against fuel spilling through and under.
It's generally 100 mil, isn't it? A bund. It's essentially forming a bund.
Yeah, that would be fine. As I say, whilst that's the case, in many situations, because of the height of a damp-proof course being at 150, often people set it as if it were 150 in the same way that you do. In truth, so long as there's a bund of some description to prevent fuel going through there, if it were to be, say, 80 mil, we probably wouldn't worry unduly about that. And alternatively, as I say, you can slope the floor surface away from the building itself to lay it to a fall. But the bit that so often doesn't get thought about is the compartmentation between that dwelling and the adjacent dwelling. So particularly if you've got a terrace, or if you've just got a semi-detached property, you need to ensure that you have proper compartmentation and fire stopping between your property and the adjacent property. Now, that requires that the compartment wall goes all the way up, and I mean all the way up to the roof surface itself. So something that can often be forgotten or just really bodged is the triangular bit in the loft between your property and the adjoining property. You'll often see half a block missing from the junction between the two. We've seen timbers taken all the way through from one property to another. Just on that point, generally speaking, rather than taking timbers from side to side, if you take them front to back so they don't go on or through the party wall, you're removing some of the difficulties that you would otherwise create in how you start to fire protect the structure.
Geoff, and in the UK, like I know in Ireland, you have to fire stop above and below the felt, and also in the eaves box, and you see it a lot that he will just fire stop to the underside of the felt, and you have battens may continue over it, so there's a gap above it, below the roof tile, and in the eaves box, it can be forgotten altogether. And a lot of people have come to me and we check it. Well, sure, I've been doing this for 30 years. Well, you've been doing it wrong for 30 years.
Absolutely. So again, I think that this would be a great opportunity to bring up the detail as well of that eaves box.
Yeah.
But if you imagine it, that quite often the roof it pitches in front of the two properties, and you've got like the gutter area and what we refer to as the eaves box continuing across the front. What that does potentially is create a route for the fire to spread through at the eaves point in that timber boxing from one property to another. So if we go way back in time, the way that used to be designed out would be that you'd have a stepped brick parapet wall. So it would actually step out at that junction, and you'd continue a brick parapet between one property and another. Now,
I just very good. That's a great detail.
I think that's a fantastic detail, and it was a fantastic detail for many, many years. But a lot of the time, the planners don't seem to like. They want a continuous roof, or architects like the sort of seamless roof that runs between the two. And in that particular situation, if you've got timber that runs from one side of the property to another, a quite common thing that people do is they'll put that both neighbours will have an extension at the same time, and the builder will take his joists, flat roof joists from one side to the other, and just and land them on the party wall, and you can literally see through from one property to another. You go, no, hang on a second. What you need to do is take the wall up and then like hang them off of that, or just take it through and separate them, but don't run the timber through from one to another. It's just a bit of a shocking detail, really, in my opinion, that just hasn't been thought through if they're trying to do that. There are ways around it. You can fire stop and effectively put block in between each of the joists. You can fire stop underneath it, and you can treat the timber coming back from one side to the other. But you're really looking at a sort of a minimum of 1 meter either side of that party wall that you'd then have to treat, which you wouldn't necessarily have to do if you'd not done that in the first place, and you've got the more traditional party wall parapet upstand detail, which usually sort of sits out about 300-400 mil above the line of the roof surface. That also gives you a great opportunity to put some decent lead work in and around that, and weatherproof. And we'll be talking more about weatherproofing and damp detailing in the next one of these when we look at part C. The other thing, depending on the type of construction that you've got, that you need to be aware of, is that a lot of the time the construction will create a cavity. So you'll perhaps have an outer layer of brickwork and an inner layer of timber. And around the windows, for example, or at the head of the cavity, or in the party wall line between the two properties, you'll again have a route by which fire could spread from one property to another, or could get into the cavity and spread up and around. So we would normally expect to see cavity barriers closing off that cavity around the windows, around openings at the top, so it can't spread in and up into the roof or from one property to another. So there's a series of details again that you need to be familiar with within the regs that help to detail out
just one thing there in the UK, is it similar to what we have, that if you have an inner and outer relief of masonry at least 75 mil thickness, that you don't need to provide cavity barriers, just close the cavity around windows and opes?
Correct. Yeah. Okay. Yeah. And then so if we're talking timber frame at the moment, because that's one of the more common forms of construction that we would regularly see. You're looking for, in particular, making sure that you have these cavity barriers in place throughout. And it's also worth pointing out that particularly some of the warranty providers have slightly differing views on this, but if you, because we're kind of moving on to the external walls as well in a moment, but sometimes you can create a cavity by virtue of like a timber paneling or the UPVC paneling on the front. So you've got just a series of batten structures, and then you've got cladding that goes across the front of the building. So you can end up creating a cavity by that. Now, in most cases, the batten can form the cavity barrier. So again, where we've said earlier about timber can actually have a degree of fire resistance, the timber batten, if we're using a timber batten, can potentially help to close off that and prevent the fire spread through the gap in the but behind the cladding and the actual main wall itself. But do watch out for that, because there have been people caught out by that detailing. What else do we need to mention? Sometimes if you have a particularly large property, multiple floors or similar, you may need to install sprinklers into the building, and you can reduce the level of fire resistance that you're putting in if you have installed sprinklers as a compensatory feature or elsewhere within the building. So sometimes that is something you might need to look out for. Actually, that was one that you mentioned last week. Let's just remind people of the one that we briefly mentioned last week, which is the wall around the escape stair. Now, the wall around the escape stair really needs to be fire protected all the way up again to the roof level, or to have effectively a fire rated cap over the top of it, so that fire doesn't spread from the rooms into that staircase. So particularly saying like a 3-story house, for example, that or a 2-story with a loft conversion, that staircase partitioning should go all the way up again through the building to prevent the fire spreading up and over the top. So what we commonly refer to as a protected shaft. So that's something else to keep an eye out for. So yeah, I think that's probably everything I can think of at the moment.
Just one thing would people I think need to be cognizant of is combination of services, because particularly in timber frame, where you have a cavity between them, if you provide services within it, a fire in one unit can readily spread in next door if you have services that are in a common wall. So compartment walls or party walls should be free from services, and you shouldn't really chase back to back as well, depending on the thickness of the wall. But it's just something that you'd see on sites, and it's more common than what you would think, and particularly in multiple units, like in apartments, particularly of timber floor construction, where you might have services in the floor, and you should really have a cavity, a service layer below it, and have all your wires and recessed lights. They should not be within a separating floor.
Yep, definitely. And as I said, likewise with the party wall. Perhaps also worth mentioning, say particularly, we mentioned last week about the need to have this fire rated staircase. It's increasingly common to see houses having mechanical ventilation to them now, so MVHR type systems. What's important with that is that ventilation system doesn't pass through the firewall as well. If it does, then it will need separate fire protection by virtue of a damper or by fire rated boxing, so that doesn't give you a route of spread of fire from the rooms into that protected staircase. So again, services can be quite an issue.
Yeah, just with that, mechanical heat recovery, mechanical ventilation heat recovery, it's generally flat pack ductwork. So if you're to put in dampers and actually smoke and fire dampers, how would you locate the IO or the smoke detector within it. How does it close it off? And then you're meant to have a damper control panel. So it's like the way it's written, or what we've noticed anyway, when you're looking at BS 999 or treble 91, well, particularly treble 91 for mechanical heat recovery, that's written, and BS 5588 part 9, the original document states that for ventilation ductwork, it should be steel where you provide dampers. These are generally UPVC or plastic ductwork, so it's not really relevant. My consultancy, we've contacted the British Standards and we've contacted the powers to be to kind of make them aware of this, because it's a grey area, and I don't think dampers are fit for purpose in this type of building, particularly dwellings. Obviously in commercial buildings they are, but it's just some detail that it's left, and I don't think it's been addressed fully. And it's an area that can give a lot of concern, because if you don't put it in, you don't strictly comply. And how do you do it? You have to reroute it around the protected means of escape, and that's what we've been advising to do. Our proprietary seals for that kind of ductwork they're not as robust as other ones, in my opinion.
Indeed. So I mean, potentially you've got routes for smoke quite quickly. So the type that tends to get spec'd for those are the intermittent close-up type, as opposed to an actual proper traditional bladed smoke damper type. Yeah. So as you say, quite rightly, and also really you want the system to effectively shut down, so you're not automatically dragging smoke from one area to another. So yes, services in particular are an area to look out for, and ideally just ensure that your services don't pass through anything that should be fire rated. Where you have to always think about, well, how am I going to detail that out, and does that actually work in real life? I think are the two top tips there. So that moves us on to B4. Now this is about fire spread across buildings and between buildings. So this really was the whole Grenfell Tower kind of situation, and the use of external burning stuff. So there's a huge trend at the moment to, for example, upgrade existing buildings by putting external insulation on them. And I think what people often forget with that is that you're creating a potential route for fire, and it's like, well, I'll get it done, my next door neighbour gets it done, and potentially you've got a route for fire then spreading across the party wall again, beyond all of the cavity barriers and stuff that you've installed everywhere else to prevent that fire spread. So look out for that. Also bear in mind the whatever you're using on the external wall, the most traditional sort of forms are generally non-combustible. So brick, block, render. Most of those types of surface are not combustible and won't generally give you an issue. But we've seen some very weird and wonderful things over the years. We've seen a lovely cork build extension, external cork effect. Which is it's definitely different. We've seen varieties of shingle tile hanging. We've seen renders. We've seen external metalwork sheets. We've seen things that are made to look like they're a metal container unit. There's no end of imaginative things that architects can come up with to stick on the outside of buildings. Now, again, depending on how you're configuring that external look, one, you've got the fire spread across that surface itself and around. If you're a detached building out in the middle of nowhere, it's probably not going to be the biggest of issues. But if you are close to other buildings, then it can create a route for fire spread from one to another. Another example of that is people creating green walls, so living walls where you put planting, etc. on. Now, often they are combustible as well. So if that's the external surface that you're putting onto your building, bear in mind that that can be a route for fire spread. We frequently see green roofs where people put the sedum stuff on the roof itself, which is great. It really helps to sort of create a bit of a carbon sink, particularly in our city centres and stuff. But you need to be wary of the fact that particularly during certain months of the year that can still dry out, and there is a route for fire spread from one property to another. So you are looking to ensure that that you don't get fire spread come up from one property, land on another, and spread across the roof surface itself. So generally speaking, on green roof, you would expect to see like a ballast strip all of the way around the outside of the green roof itself. That's not just there for drainage or etc. It actually helps to prevent the fire spread from one property to another. Some of the really weird things that we have seen someone attempt to put artificial grass down on top of their felt roof, and we have pointed out, hang on a second, that very much is burning stuff, and we do control the flat roof surface as well. So you would your more traditional felts etc are fine. You can get paving slabs over the top. You've obviously got your concrete tiles, for example. Really weird, I say really weird ones, very unusual these days ones, which is the real traditional stuff like your straw thatched cottages and stuff. Lovely traditional buildings, but huge risk of fire spread from one property to another. So there's a whole lecture we could do just on how you deal with thatch and how you prevent fire spread from one property to another. So that's the walls themselves, and again, depending on the height and nature of the building, that there are these Class C S3 D2 type requirements that you may have to be complying with. One that is often also forgotten is about fire spread from one property to another. Now, this is where the conservatory type extension, this lovely glazed building that gets stuck on the back, that's so beloved of architects, often falls foul of, because there's a limitation on the amount of non-fire rated construction that you have from facing from one property to another. So if you go to the approved document, there's reference to what's called unprotected areas. Now, typically this is areas of glass, it's windows or openings, but it can also be an area of wall that simply doesn't have the plasterboard on the inside of it, for example. So occasionally architects do come up with something a bit weird and wonderful to fit on the inside, like cork, for example. So unless that's on top of a fire rated board layer, then there is a risk of fire spreading from your property to the adjacent property. If you are more than a metre away from the adjoining property, then whilst there is a limitation, the limitation increases effectively with every couple of meters that you go, to the point where if you're like 10 meters away from the adjoining property, you could have almost entirely glazed elevation to that side.
Or cork.
Or cork, yeah, if that's what you would particularly like. So you do need to consider the risk of fire spread from one property to the adjoining property through the wall itself. Now, when we're talking about glazing, it doesn't mean to say that you can't have glass. So you could still have glass, but you'll be spending a lot of money doing it. And this is why, because you can get a glass that has a heat retaining property. So typically it's got an intermittent layout within the glazing itself, and will actually prevent fire spread from one property to another. Because you can, when we're looking at it, we're looking at radiated heat as well as direct heat. Okay, so the glass might stay in place like I'm sure everyone's seen the glass with the wire within it, which is typically referred to as Georgian wired cast polished plate glass, which is the one that's got the metal in it, which would hold the glass in place. But that wouldn't necessarily prevent the heat or the radiation from one property spreading to the adjoining property and catching that on fire. So you would have to have a glass in that wall that helps to prevent that radiated heat between the two properties. So again, that's another one to look out for.
What Geoff is elaborating on there is like the Georgian wire glass is considered to have fire resistance in terms of integrity, is because the wire in it doesn't fail, but it does allow heat transfer through. So it's an insulated fire resistant glazing, and it is like not alone the glass, but it's the frame that goes with it. It's extremely expensive. Like you could be talking, well, I know in Ireland it's $550 a square meter without the frame. So it could be thousands just to keep a nice looking detail for your architect. I'm not giving out an architect here, but just to keep a nice detail, it could cost you a fortune. And it's just something to bear in mind, that is a very, very expensive detail.
And again, that is another one of the occasions where sprinklers can be used as a factor to enable you to get closer to the adjoining property, or to have a greater amount of glass or unprotected area to that elevation. So that brings us on really just to one final area as we're looking to wrap this up, and that's B5. Now, B5 is about fire service access to your building. So in the event that there was a fire, there is a risk that someone might need to be rescued from it, and certainly you'd ideally want the fire service to be able to get there to assist you to get out of the building if that's what it comes to, and certainly to try to put the fire out or try to control the fire to minimize the amount of damage that's actually done to the structure of your property and to adjoining properties. So there's a series of requirements in B5, again based predominantly on the height and nature of the building itself, that control how close the fire service have to get to your property, with a typical requirement that you would need to be as a sort of absolute maximum sort of 45 meters away from the building, but with an area, an amount of the perimeter the fire service would need to be able to get to in relation to that building. This can cause a lot of problems with what we would refer to as backland developments. Now, what's a backland development? That's often where there's a plot behind an existing terrace of houses that's got room enough for, say, a car or an alleyway to get to, and then there's a big plot behind it, and you might be wanting to put 3 or 4 houses on that big plot behind it. But the problem is that the fire service can't get their fire appliance down that narrow lane. Sometimes it can be wide enough for the appliance to get down the lane, but it's a long lane to where you get to the new housing development itself. So there are limits on how far fire appliance can go. So, for example, in addition to the 45 meter requirement, there's also a requirement that the fire service wouldn't have to reverse back down the alleyway more than 20 meters. So you would have to then create a hammerhead or a turning circle at the end to enable them to turn around and come back down the lane or the gap that you've got. So that's certainly a concern that you would need to have if you're developing a small backland site in particular.
Just wondering, has any thought, I know that's to do with health and safety with regards to, and maneuverability of the tender, but with advances in technology where you have parking sensors and reverse sensors, I wonder, could that be extended, or like, I'm not sure if anyone's ever brought that up with the powers to be, that, you know, the people could be safely reversed a bit more.
I think part of the issue is trying to understand in particular why that requirement was there. So so there are a couple of bits with it, because quite often there's a discussion about, well, why can't the fire service go 50 meters? What we'll do is we'll put in a piece of dry pipe, and they can connect to one end and they can connect to the other. What you've got to bear in mind is that the fire officers will be going into an intense fire situation. So they're going into it. So they're going to be having to carry breathing apparatus. They're going to be having to carry lengths of hose. If you think it's a good idea for them to go further than that, go have a day out with the fire service, get yourself a full set of BA on, grab yourself a couple of lengths of hose, and go run 45 meters with all of that gear and stuff to carry on. And you'll see it is quite an intense thing to actually expect them to do. Likewise with the reversing aspect, if that property is starting to fail, despite their best efforts, the fire is running away, they're going to need to get out of there quickly. They're going to need to get that appliance out as quickly as they can, and obviously as many people on board and quickly away. We have seen situations where obviously they're then trying to do that. So it's not a case of, oh, what I do is I'll just quietly reverse back and listen to me sensors as I go down. It's a case of, let's get out of here before that building comes down on top of us, kind of thing. So you'll remember when we were speaking about the means of escape aspect, you might be wanting to, in order to fight the fire, get as close as possible to that building. Yeah. If that building is 10 meters in height, they need to get back 10 meters away from it. Otherwise, that brick elevation could be coming down on top of them. So,
yeah, I know.
The requirements are that, yes, modern technology is great, and putting sprinklers in always is a very, very good idea, because if the fire service are delayed, you never know what the traffic situation is going to be like. You never know whether there are going to be other fires that are happening at the same time, or what the fire service resource or response is going to be able to be. So sprinklers are always a great option, which will help to protect you, protect your family, protect your property, regardless of whether the fire service can get there or not. And there are examples where you can use the sprinklers to help offset some of these B5 requirements. So there we have it. We've just had a quick run through in today's session of B2, which is internal fire spread and wall and ceiling linings. We've gone through the fire resistance of beams and structure, compartmentation issues. We've looked at external fire spread and compartmentation between buildings, and we've looked at B5 as well, which is about fire service access. So tune into the full episodes and keep coming back and finding out more each time, because there's going to be more and more of these. We're only up to B on our journey through the A to Z of the regs. So come back and join us next time.